I think no, sir.
Okay, awesome. Let's get started. So what we'll do today to begin with is we'll try to look at some of the data sets, okay, with SQL and API. Um, and then we'll move forward from that. So we'll just examine few data sets. I'll tell you where these data sets are, right? So last time, what we discussed was trading data is the most important thing. And without training data, you cannot train really machine learning model. Now, of course, I told you that training data will be provided by the domain experts. Um, whenever you are solving problem in your, let's say, in your corporate setting, or if you're working for someone, but while learning machine learning, right? Or even while you are solving some problem, sometimes what happens is that, let's say, you're working in a services companies, and customers generally do not share their data because data is quite confidential. People are very very skeptical about sharing their data due to privacy reasons. So at that time we need some data sets. So what we do is we look for similar kind of data sets in the public domain, and then we build our model on those data sets. And then that model we apply on customer data, or we share that model with customer apply it on their own data set and judge how good your model is. Of course, it's not the best way of doing machine learning, but that it could be the compromise, because of a lot of other restrictions. So the question is obviously, where do we see such kind of data sets, and how can we use those data sets? So that will mainly be the topic of today's discussion. So we'll also be doing some coding. If you are also in front of your computer, I would strongly urge you to follow me along. I mean, try to also code alongside me, so that you get this content, far better than just listening to it, or just by observing what I'm doing. Okay. So let me write down. So we will look at the sources of data, and we'll see how to access these data sets with sklearn. By the way, sklearn is a library, is a Python library that we will be using throughout this course. Okay, this is our lecture number 2. Okay, we'll start on a new page. Okay, so what are the sources? Let's note down the sources. One is sklearn itself. Sklearn has some pre-packaged data sets. We'll look at them. Then UCI machine learning repository is another place where you can see a lot of machine learning data sets. Then there is Kaggle, and all of you should be aware of Kaggle. Kaggle is a data science platform for hosting different data science competitions. So Kaggle naturally has lots of real live data sets. sklearn also has, you can also generate data sets for problems like regression, classification, and clustering. So you can also generate synthetic data sets, and these synthetic data sets can be generated with specific attributes. So we'll see how to exactly do it in detail later, but sklearn also has its facility. So if you don't find data sets that is closely matching to your problem, you can also generate a synthetic data set and work with that. Okay, then UCI machine learning repository, I will try to create a link, put a link for that. So this is UCI machine learning repository. It has got a very large number of data sets. So you can see here there are 622 data sets. Right. So I will also add this. Yeah. I'll also add a link to Kaggle. So kaggle.com is the Kaggle competition page. And later, in this course, we have a project which we host on Kaggle. So all of you will get familiar to Kaggle in due course of time. But you can see that there are data sets in Kaggle. There are data sets in Kaggle. Well, many data sets. So these data sets are also tagged with respective tags. So there are 9,425 data sets in Kaggle with tag computer science. So you can see data science salaries for 2023. So this is one of the data sets. And you can see that there is a data set card. So it lists different columns. So there are about 11 columns. And the description of each column, right? Work year, the year the salary was paid, experience level, the experience level in the job during the year, employment type, job title, what is the salary, what is the currency of the salary, what is the salary in USD, and then where is employee resided, uh, what is the overall amount of work done remotely in the company, right? Then location of the company, the country of the company's main office or contracting branch, and company size. So these are 11 columns, and I think we can predict one of these. Either we can predict salary or salary in USD, just for keeping it uniform. So what is this problem? What is this type of problem? Is it a regression problem or a classification problem, or is it an unsupervised learning problem? What do you feel?
So it's a regression, I think,
So
Why is it
regression.
a regression? Why is it a regression problem?
because the salary is continuous. It is not a discrete value.
Like we are predicting
Great.
salaries there, so the label is
Okay.
continuous.
Great. That's really great. Um, yeah. So this is one of the data sets that we have seen. Just admitting. Can you admit this person? Okay, admit. Right. So this is data science salary. So this is Kaggle platform. You will see a lot of such kind of data sets there. These are some of the trending data sets. So there is air quality data, the popular baby name data, right? So these are some of the popular data sets. So you can also look at, let's say, computer vision data sets, right? So this is for mushroom image classification. So it has got 3122 images. Each image is 512 by 512 of 215 different mushroom types, right? So what do you think? What is the type of this problem?
So multi-class classification. So
Okay, multi-class classification. Anyone else? How many classes are there?
so 215.
Yes. So more than two classes, it's a multi-class classification problem. And of course, we are making an assumption that each image corresponds to one type of mushroom. That's the assumption we are making.
Sir, I have a question here, sir. So what is the
Yeah.
difference between multi-class and multi-level classification?
Yeah, we actually spent a lot of time last time, but I'll repeat
Okay,
it once.
okay, sir. I
Uh,
didn't there. I did not
you
join.
were you did not join, so maybe you should watch the video.
Yeah, yeah, sir. Okay, okay, okay. Yeah.
Multi, yeah,
Sir,
multi-label means there is more than one label for a given data point, right? So for example, here is a fruit basket. If I ask you to name all the fruits in the basket, this is multi-label classification, as
Okay.
well as multi-class. Multi-label meaning there are more than one outputs, and
Okay.
multi-class because each output potentially has more than two choices. That's why it's multi-class.
Okay. Got it, sir. Thank you,
Sir,
sir.
when we say that each output has more than two choices, it's the same for label as well as class.
Yeah, label and class. Yeah, so here this is one choice. This is one label, right? For this label, there are multiple choices. Multiple fruits could be here, right?
No, when we say it's a multi-label problem, that is that sufficient, or do we need to extend it to multi-class also? I mean, why do we need to bother by whether it's multi-class or not?
Yeah, I mean, we are just explicitly saying that this is a multi-class problem also. It's multi-label and multi-class problem. Were
Yeah,
you there
but
in the
when we,
last class?
yes, I was there and I was listening to everything. But
Okay,
I
okay,
had this
great.
question from the last class. It's like I couldn't
Okay.
ask last time. My thing is that when it is a multi-label problem,
Okay, no
okay,
problem. So what is your question?
my thing is that
Mhm.
it's a basket of fruits and we are, I mean, the classification is able to tell which one is banana, which one is orange. That is okay. What is the need to tell whether it's a fruit or not?
Whether it's a fruit or not, I didn't get your question. Sorry. Could you please repeat? Okay. Are you there? I think I lost.
Sir,
Yeah,
hello.
wait. I think let me finish answering the first question. Bimlesh, could you please repeat it? I didn't get your last part. You said fruit or not. I didn't understand that part. I think did we lose him?
I think he has lost his connection.
Yeah. Oh, go ahead, please.
Look like he's on
No,
mute.
I think he has lost his connection, sir.
Okay. That's okay. But you have a question, right?
Yeah. No, I was just trying to say what he was saying. I was just taking it further. Since this basket
Mhm.
has only fruits, right?
Right.
So, and there are different types of fruits. So, can we say that's a multi-level problem? Like all of them are fruits. Say, for example, if there could have been vegetables also, like fruits and vegetables together, then we could have said that class, two classes are there. Like one
No,
is
no,
the
no, no,
fruit
no,
class.
no, 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 no. It's not class is not used that way. Class is within how many types of labels we have. That's a class.
Yeah, that's a class.
How many?
Say for example, I'm saying good or bad, right? Or I'm classifying positive or
Hmm.
negative. So there are two different types of classes, right? Here,
Yeah, there are.
since
Yes.
all banana, orange, grape, pineapple, everything belongs to fruit class. So can't we say it's a single class
No, no,
problem,
no.
but multi-level problem?
No. It is not a fruit class, right? We are not saying that whether there are fruits or vegetables in the basket. It is not like that. I want to know. I want to basically label each fruit that is there in the basket. In that sense, it's not
Okay,
whether.
in that sense, yeah, in that sense, then it's a multi-class, right? Because different each fruit we are calling it as a class, right?
Yeah. Each fruit is a class, right? So that's why it's
Is
multi-class problem. It's multi-label
No. When we say
because
each fruit is a class, what do we mean by that? Because either it's a banana or orange or whatever, if that is sufficient to uh, sufficient regarding our investigation about the fruits, then what is
no, it
there
is not
more to?
sufficient. No.
No,
So
it's a
see, I
fruit,
mean,
it's a basket of
see, let's say you are
fruit.
solving this problem on the table, and you have developed a mobile app, for example, which takes a picture and which tells you what all fruits are present on the table. Correct. Now you would ideally like to label each and every fruit that is there on the table. Correct. So in that sense, now you are going to tell what are the fruits that are present, right? And each fruit there are, let's say we fix number of fruits that we are going to recognize in this program. Let's say we fix 10 different type of fruits that we are going to recognize in this program. Now you have to basically you have to take each fruit, and that each fruit potentially belongs to one of the 10 classes. correct? And these are 10 different fruits. So in that sense, it's a
Which could be
multi-class.
those 10
It's a
different
multi.
classes? Sorry to interrupt, but which could be those
No,
10
no,
different classes?
that that you can fix. So I can say that
So is it
mango.
like something like citrus fruit or something like
No, no,
tropical
no. I
fruit?
mean, we can fix them. We can say that mango, banana, jackfruit, sapota,
Yeah, but then
lemon.
that is not the class. That is the label of
Okay.
the fruit.
No, no, no. Don't. Let's not debate about class, right? So this is a technical term that we use in machine learning. So class is a term that we use, which basically labels the data point, right? It's used in the context of label.
I think, sir, the main
I think
clarifying.
I
So just last statement, sir. I think just last statement of this topic. I think the main.
please.
I think the
I think
main.
we spent we actually spent a lot of time in the last class about this. So I'm okay to spend few more minutes, but let's quickly go over it. Otherwise, we'll continue discussing this and we'll never make any move forward. Go ahead. Go
So
ahead, please.
line. Yeah. Am I audible, sir?
Yeah, you're audible.
Yeah, I think the main clarification line is that we are treating each fruit as a class. And since there can be 2 bananas or 3 bananas in the basket, that's why we are saying it is a multi-label, right? So now it is clarifying all the
No, no,
doubts.
no, 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 no. It is not multi-label because there are 2 bananas. It is multi-label because this particular data point is getting more than one label. That's why it's multi-label, right? We are getting more than one label. Here there are
It is
4 labels
multi-class
that
because,
we
and we are calling
wait.
it multi-class because there are different types of fruits, right?
See, last time we had a lot of
Got
discussion
it,
about
sir.
this.
Got it.
It is
Sir,
multi-label. It is
sir, sir,
multi-label.
I think we should move on. I will read about it further and put on Discord. Thank you.
Yeah, please read it and let's ask this question next time again. But I'm again making it very clear that we are calling this as multi-label because there are more than one output. There is more than one label that we are assigning to a data point. That's why it is multi-label. In this case, we are assigning these 4 different labels to this fruit basket. And each label that we are assigning, right? For each label, there are more than 2 choices that are available to us. That's why it's multi-class, right? So for example, I'll tell you a single label example. Let's say you want to know whether a transaction is fraudulent or not. So for every transaction, we are assigning exactly one label, which is whether it's fraudulent or not fraudulent. So it's a single label problem. And there are 2 classes. Transaction is either fraudulent or not fraudulent. So it's a binary classification problem.
Thank you, sir.
Yeah. All right, let's move on. Yeah, so I was listing out some of the sources. UCI machine learning repository, Kaggle, and then there is something called as OpenML. OpenML is another website where which has got large number of data sets, about 5,291 data sets in OpenML, and we can also get data sets from OpenML for our work. So here we can look at some of the data sets. So, this is a card. There is a detail about the tasks. It's a supervised class. It's a classification problem. They want to predict a class. And let's look at the data set if we can somehow. Yeah, they will. Okay, I am not sure if we can see the data set here. You may not be able to see the data set here. Anyways, but we can load this and see later. So I'll just add OpenML. OpenML is another repository. So these are some of the repositories where we can see these data sets. So let's actually open a Colab notebook and try to load some of these data sets and explore them. So it will be fun. You will get to also, get your hands onto sklearn library. So let me open a Colab. So I'm sure you have gone through week 0 content, which has got collab. So you can open collab by following.
Yes, sir.
Yeah, I'll present my screen. Wait a minute. So you have to go to collab.research.google.com. So you can reach collab by typing. I will write that also on our notes. So open collab notebook by visiting. I'll also paste this message in the chat box here. Okay, so open this link. You'll be there in collab. You need to log in with your Gmail ID so that yeah, and once you're in collab, click on new notebook. Is everyone with me so far?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, please open a notebook. So we have a notebook. We need to first name this notebook. So I say dataset demo. Right. So now this notebook, you can say.
Sir, your new notebook is not visible.
It is not visible for you.
What we can say is welcome to
Okay.
college.
I see. Sorry, I didn't. Okay. So this is my new notebook, and by default there will be untitled here. So I have changed it to dataset demo.ipynb. ipynb is the collab extension. It's interactive Python notebook, and this notebook will be stored in your Google Drive. Okay. Now we need to connect to a cloud runtime. So you'll be allocated a virtual machine in the cloud where you can execute your code, Python code. And you can see that the machine that we have gotten has got 12.7 GB RAM and 107.7 GB disk. And it is using Python 3 by default. Are you getting it? I just clicked on the resources here. I clicked on the view resources, and you get to see that this machine has got 12.7 GB RAM and 107.7 GB disk. Okay, and
Sir,
it is using Python 3. Yeah, go ahead.
I'm getting you are not subscribed. You currently have 0 compute units available. Is that something which is to be worried about, or
No, it's
updates
okay.
automatically?
That's okay. You don't have to
Okay,
worry.
thank you.
You were able to connect, right?
I was
See,
able to connect, sir.
I'm also seeing this, right?
Yeah.
You're not subscribed. It's okay. You don't.
Okay.
You will need probably more of these things if you're running a long running job or your job requiring a lot of more memory. But whatever work that we are doing so far, I mean, we don't need anything extra.
Okay,
This free tier will work totally fine.
Okay.
Okay. So in Colab, there are two cells. One is text cell and second is the code cell. Code cell is where we write our code. And then there is a play button here. When you click on this, the code in that cell executes. So I can write something here, right? I can, put a title. So we can write here in a format called Markdown. Markdown is a language or is a formatting language, just like HTML, that you can use to write decorative text within these text cells. So I can say that dataset API, SQL on dataset API. So you can see that you have gotten a boldface, right? Just like H1 in HTML, this is equivalent of H1 in Markdown. You can also use these controls. Now, so I will write something. sklearn library provides a dataset API. sklearn.datasets. Okay, so you can see that whenever I'm putting something in, in single quote, not exactly single quote, but the symbol that is there just before tilde, markdown outputs a fixed length font for that. Okay. So
if you don't mind, I want to ask a question here.
Yeah, sure.
Sir, what is exactly an API call? I just want to know the broad meaning and
Yeah. So API is called Application Programming Interface. So this particular library will provide you, some kind of functionalities, which is already implemented for loading these data sets, so that you can do this very quickly. You don't have to write everything from scratch. Okay.
So an app is also an API or like that?
App is not an API.
Okay. And website?
Website is also not an API.
Okay. We use API to interact with the
website. Let's say you are let's say on a reservation, let's say a railway reservation website, right? IRCTC, where you are asking to get you the list of trains. So list of trains is what is an API that IRCTC uses internally. They may expose it to you or may not expose it to you. It depends on the provider. Okay. So let's write some interesting. Yeah, so sklearn datasets is the dataset API for you. And let's see what kind of datasets are present. So I'm actually going to show you sklearn user guide. So get used to this sklearn user guide. You need to read it. In my recorded lectures, I have taken a lot of references from this, and we have used it for creating notes. But in the live teaching, what I'm thinking is that I'll not go into a lot more details of each and every API, which you can read easily, and we'll rather focus on more of a practical aspect. So get used to, let's say, these APIs. So you can see here is that there are some general data sets that sklearn has. There are some toy data sets. There are some real world data sets. Then you can generate also data sets. I told you that we can also generate data sets, synthetic data sets. And sklearn also has facility to load other data sets. So other data sets means, let's say, data sets from OpenML, or you have your own data set, which is, let's say, in CSV format or in spreadsheet. We can also load those data sets. So we'll see how to use exactly this functionality later in the course when we will take a deep dive into this dataset API. So the goal of showing you this particular thing, this particular collab demonstration, is to load some data sets and explore them, just to get a feel of let's say features and labels and things like that. Okay, so we'll first look at toy data sets. So there are about 6 toy data set. One is called iris data set, and then there is diabetes data set, digit data set, physical exercise data set, this wine data set, and breast cancer data set. So you can see that most of the data sets are for classification. The diabetes data set is for regression. Okay, so we will, and you can also see the description of each of the data set. For example, iris data set has got 150 examples, and there are 3 classes: iris setosa, iris versicolor, and iris virginica. Right. So what is this classification problem? In terms of, is it multi-class, is it binary classification problem?
Multi-class.
Great. And is it a multi-label or single label problem?
Single label.
Single label.
Great, single label problem. Good. Yeah, so there are 4 attributes per row. So every example has got 4 attributes. One is sepal length, sepal width, petal length, and petal width. And based on these 4 features, we have to predict the class of the flower. Okay. Then you know the name of the who created this data set. So it was created by R.F. Fisher. It was donated by Michael Marshall in 1888, something like that. So all that information you will find here. You'll also see the references where this data set has been used. Then diabetes data set again uses 10 columns or 10 features, and the target is a quantitative measurement of disease progression, right? It could be H1, what is it called? HbA1c, right, in diabetes. So that could be the target. So what is this type of problem?
It's a regression.
It's a regression problem. Great. Yeah, quantitative measure, right? So we need some real number output. All right.
It could be a classification only if you want to put the bucket of HbA1c, which range it falls into.
Yeah, of course. So you can also define it that way. That's not a problem. Yeah, you can also make a classification problem out of it by doing some bucketed things. That is also fine. Okay. And what kind of classification problem that would be?
Multi-class.
Multi-class.
Multi-class. Yeah. It could be multi-class. You can also make a binary out of it saying that whether a person is diabetic or not or whatever. Right?
Sir, may I ask a question here?
Yeah, sure.
Earlier you were mentioning that multi-class means in same label, in like, let's say bananas, you may be having 2 or more of the kind.
Not of banana, not of the banana. There could be more than 2 types of fruits present in that basket.
But that
Or
I thought you mentioned was multi-label.
No. Multi-label. Okay, so multi-label is that particular fruit basket got multiple labels, meaning there are multiple fruits that are present, right?
Okay.
So I'm saying that if you output more than one class, then it becomes a multi-label problem.
Multi-label. Okay. And multiple classes is multiple classes on there.
Yeah.
Okay.
Multiple classes meaning for every label there are multiple possible choices.
Yeah. Thank you, sir.
No problem. It's confusing and a lot of people get confused. I also get confused sometimes about it, but yeah, so it's good to ask questions. Do read up if you have more questions.
Hello, sir.
Yeah, go
So
ahead.
why diabetes is a multi-class? Because there is a diabetes or not diabetes?
No. I mean, no. Here he was saying that he wants to, let's say, bucketize the range of HbA1c, right? Whether it's uncontrolled diabetes, it's just borderline.
Okay, type 1, type 2, different type. Okay.
Yeah, whatever. I mean, you're free to use your labels depending on how you want to solve this problem. Okay, so let's try to load this. Let's try to use this load iris. Let's load this data set. And by the way, when we load the data set, right, we can either load this as a bunch object, which returns us a tuple, data and target, or we can also load this as a frame. And when we load this particular data set, every data set, by the way, has got a bunch of different things. It will give us data. It has got target, then the feature name list, the target name list, and there is a dataset description also that you can read. Okay, so let us import the load iris dataset. We'll first let me add this. Let us load iris dataset. Okay, so the first line is we say from sklearn import. Yes, from sklearn dot datasets import load iris. Okay, now you can run this. Yeah, if your execution is successful, you see a green tick here. That means the execution is successful. Now, if you want to know more about this load iris dataset, you can put question mark and say load iris and run this. You can run it by clicking on this, or you can use a keyboard shortcut called Control Enter. Okay. Now here, when you do this, help appears. And here in this help, you can see what kind of parameters to use. There will also be a code snippet, small code snippet that you can use to load the data set, right? So if you load a data set the way they have given here, we'll try using that first. We'll say data equal to load iris. Now this data is loaded, so you can just try to see what is there in the data. Yeah, now you can see that this data is, so by default, what do we get by default? By default, it returns xy. So sorry, this is default, this is false. Default is false. This also false. Okay.
Sir, why is there an underline in load iris question mark that cell?
This underline?
Yes.
I think it is not able to, it is because of some kind of spell check that it does. Right, that's why there is a red line here. You all are able to see the font, right?
Yes.
Okay. Now you can see that in this data, this is some kind of a dictionary. In this dictionary, there is a key called data. And in that you see these 150 examples. Okay, then there is target key, which will have again, it's a list, which has got again 150 examples. We will individually check the lengths. Then target names. So it says that the possible targets are 3 targets. The flower is of type Setosa, versicolor, or virginica. Then there is dataset description, which is here.
So what is target array?
Target is a class, a number of classes. These are class labels, right? There are 3 classes.
No. Previously there is a target array.
Where is target? Okay, this target array, this is the class label for every example. So the 0 is the label for the first flower, and first flower has the first flower is described with these 4 numbers. Okay.
This is the iris dataset.
Iris dataset, yes. Huh? All right. So this is how, yeah, and you can also see the feature names. Okay. Let us look at, so we had data dot shape, for example. Let's see whether it works. This did not work. This is a tuple. So how do you do it? So data. What is there in data? So we have an array, and we can see, let's say, length of this array. So length of this array. There are 150 entries in this array, and
so it's a NumPy ND array.
It's ND array, right?
Yeah.
How do you see the shape of this array is what I'm wondering.
You can do dimension.
Dim ND dot.
Yeah, I think dimension will work.
So you can use a shape without the brackets.
Okay.
Like
let me see.
Yeah.
Correct. Good. So this particular thing will give you the shape of this array. So there are 150 examples, and each example has got 4 attributes or 4 features. In the same manner, so it's good to write comment here, right? We say that it's.
So why here you do not do data.shape only rather than data.data?
No. This data, right? This data is the.
Okay. Is the name of the
variable. Yeah. Let me, if this is confusing, right? We say this is iris data. This is iris data. Let me do this so that, this is a bad choice of the variable name.
Sir, one more trick we can do is in our load iris, if we do Aj underscore frame equal to true,
yeah,
it will load as a data frame.
yeah,
And
exactly. Yeah. I actually use the default parameterization. Now you can see target shape. And you can see 150, right? So this is a sanity check. There are 150 example, and we have this is a list. This is the shape of a list. So there are 150 values in the list. So we know that every example has a label. Okay. Then you can also say iris underscore data dot description. Why is it not working? Oh, R, there is one more R here, right? Description should work. Let me do import tprint. Let's try. Doesn't work. Why? It's okay.
Should there be brackets after the DCR, sir? Just a
No,
question.
no. It is basically a key, right? In this dictionary, it's a key. So we don't need to have bracket after that. I'm just using the key here. Right? So you can also, okay.
So can we write it inside a print statement or normal print statement?
Try it. Try it. I did not try. Yeah, that's a good idea. You get, get a nice print. Thanks for suggesting. Let's print the data set. Description. Right. Now you know that, you can read this up. There's summary statistics and whatnot. Minimum value of sepal length, sepal width, petal length, petal width. Okay. You can also, this is a summary, right? So we can say, what are the classes? What are the names of the classes? How do you get it? Sorry, we'll do it here. This one will delete. Iris data dot target names. So these are the names of the classes. Then iris data dot feature names will get you the names of the features. So the sepal length in centimeter, sepal width in centimeter, petal length in centimeter, and petal width in centimeter. Okay, got it. So by default we had this in dictionary format. We can also load this as a data frame, and for that we'll have to basically say as frame equal to true. Now you'll not you basically get the data frame, and you can say shape of this data frame. Oh, shape doesn't work on data frame, is it? What works on data frame? Data frame dot, let's say, summary or description. Describe, data frame dot describe, I guess. No, that's strange.
Sir, you have to write areas data dot data because you didn't.
Iris data dot, but I don't know. It is supposed to return. No, this don't work. Now it will return this as a
Return
frame,
FY,
right?
Yeah, but
Wait,
you
wait.
didn't do return XY as too.
Okay, no, I said as frame, right? So this should come as a pandas data frame. Okay, I see. So we'll have to basically get two
Yeah.
things here.
Pandas
Return X
Data.
and Y. X will be the data frame, Y will be a column vector.
Yeah, yeah, that's what we are doing here. Yeah. It doesn't work. So we'll have to also say return XY, is it? This is strange. This is quite strange. Let's see. Yeah, this
So if you
seems.
don't, it will be a bunch object. So that's why to avoid that.
I see.
Yeah. So this was actually a quiz question last time.
I see. That's good. But this should work. Describe works on data frame, I guess.
I think sir, shape also works now.
Yeah. See, this describe works now. Describe basically tells you the so these are part of data exploration, by the way. After getting the data, it's a good idea to
Why
explore
it was
it.
not working previously?
It was not working because we didn't get the right return types.
By
Somebody
default,
said,
it was a
right?
bunch.
We are
It was a
getting
bunch object. It was a bunch object, sir.
a bunch object. Yes, we are getting a bunch object by default. So you can see here. So we have to basically put this to get data dot target instead of a bunch object. Otherwise, it gets a bunch object. So you can see that if true data, including columns with appropriate data types, target is pandas data frame or series depending on number of target columns. If return XY is true, then data target will be pandas data frame. So if you want to do this, you have to also set this to true. But I failed to understand if we say this just as true and set this as false, what would happen? Again, target is a pandas data frame. This is something that is puzzling me. I am going to try.
Sir, once you do that, you can put a type around that return object. It will show you the bunch after.
Let us try that.
Yeah.
It's going to. I'm not going to do this return true. What happens? What does it return? Let me see. What does it return? I see. It returns a bunch. Wait, data. Iris bunch. Iris bunch. But then as frame equal to true doesn't make any sense, right?
So you can type within bracket iris bunch as the object. So you can show the data type of that object that return.
D type, right?
Just type.
Okay.
Sir, now you can use iris punch dot data and iris bunch dot target, and you can give it to action like.
Let me
So
see.
here you can see it's a bunch
this
object.
Is bunch object.
Yeah.
With this is data frame. Good.
Correct. Yeah.
And target should be series. Good. But yeah, this is interesting. If I just do it like this.
So it is a single label. If it is a multi-label, target will be a data frame.
Yeah, that's correct. That's useful information. Thank you. And let's see if I don't do any of these things. Let's see. Iris default data set, and we say type. Okay, it was also a bunch object. So bunch is nothing but now. Let me see. Dot data. Okay, it was ND array then. Now it is a data frame. Good. All right. Cool. So any questions about this?
Yes, sir. The iris underscore data dot describe is not working for me. I'm not able to understand what I
It
typed wrong.
is not exactly describe, but it is
DSCR, that was working.
DSCR.
That was
DSCR.
that
Yeah,
was
yeah,
working.
yeah, yeah. You have to do it like this.
Yeah. Sorry. That was working, but later you also typed iris underscore data dot describe.
Oh, that won't work. I was trying that. But that wasn't really on the. I was trying it on ND array or something like that. That's why it was not working. But if you say load this as frame equal to true, and then if you try to describe this, then this will work. Because now we have a data
Okay.
frame. Now we have a
Okay.
data frame.
So the complete command above iris underscore data labels, that entire thing has to be there above, and then describe will work.
Yeah. This will work.
Okay. And can you elaborate on this bunch, sir? I have no clue what it is.
Yeah. Bunch is a type of it's a data type. Bunch you can think of as a dictionary. So let me explain. I'll take another question. I'll wait for a minute. So this is the bunch data set. Don't be afraid of experimentation. Just write it and see what happens. Now see, I just printed this. The bunch is nothing but a dictionary.
Okay.
It has got a key called data. It will have data. It will have another key called target, and you will see
So
the
basically
targets
the
here.
entire thing,
Yeah,
whatever is there is data. Okay.
yeah.
Target frames, target names,
Yeah.
DSCR. Okay.
Yeah. This is a bunch object. Bunch is nothing but a dictionary. Think of that.
Okay.
Yes. What was another question? I think someone was asking question.
Sir, if you could scroll up to the code before this, where you put iris data and labels is equal to the last part of it.
The last part.
Just prior to what you just showed just now, the bunch part. Where you put in brackets. I just want to know why we put in brackets. Like
which brackets?
I think you deleted that particular code.
Yeah,
Just the code before this.
Probably iris underscore data comma labels, sir. You had it in brackets.
Yeah, this one, this 29.
This
Why
one?
are we putting in the brackets?
Okay, because it returns a tuple. It returns
So
a
this is a
tuple.
tuple of data.
Yeah, it is a tuple of data and the labels.
Okay, and what do these tuples contain?
This contains the features and this contains the class labels.
So these features are not in data frame?
Yeah, so this is the data frame. This is a data frame. Yeah, go
So
ahead.
this is a tuple of a data frame and a series.
Series, yes, because we have a single label problem. If we have a multi-label problem, this will also be a data frame.
Okay. Thank you.
No problem. Yeah, another question. Another question. Somebody was trying to ask a question. Yes. All good? Should we move ahead?
And from the bunch, can we extract whatever we want? The way we were doing earlier? Then what is the reason why we need the bunch, sir? Like earlier also we were trying to extract the data part of it, the target part of it, target names,
right?
Everything we were getting. So why do I need a bunch?
Are you saying bunch or data frame?
When we actually did iris underscore bunch, what is it? What is that we're trying to get?
So when you were using iris data as a bunch object, right? You were basically getting this data set as in ND array, in dimensional array, NumPy in dimensional array, right?
Yeah.
But sometimes when you get them as data frame, you can use a lot of other functionalities of the data frame very easily. Something like you can use a data frame to describe, and then you quickly see, you can quickly explore, right, how each feature is looking like.
Right.
If you use bunch object without getting this as a frame, then you will have to write these codes on your own probably. You don't get this out of the box functionality of data frame.
Okay.
Yeah, so it depends on what is the input that is expected by your, let's say, training algorithm. Based on that, you can use. Plus,
Sir, let's move forward. In that, I will answer all this kind of questions.
Okay, Manoj. Okay, Manoj, that's okay. No problem.
Everybody, please ask kind of question. Then I will be here. I will answer all of you.
All right. So can I ask you to explore, let's say, diabetes dataset on your own, or maybe we can do that one more exploration. This one was we were doing a lot of back and forth, so one clean exploration we'll do, and we'll stop. We'll now load diabetes dataset. Okay. Or instead of doing diabetes dataset, I'll load image dataset so that all of you get some idea about how the images are stored. Okay. So what is the image dataset that we have? We come here. Now let's go back. So load digits. Let's do load digits. So load digits is, it has got 8 by 8 images. And again, we'll use load underscore digits class from datasets API. So again, very simple. From sklearn.datasets, import load digits. Click on this work. Okay, it is connecting to the runtime. So don't worry, we'll have another very detailed session on the dataset. This one I'm actually doing it to show you different type. I mean, how to load data in sklearn. Okay, so we say digits dataset equal to load digits. Okay. By default, a bunch object. Now this is interesting. I want you to read these things. So data, yeah. So we have some arrays, right? You can see something, and then we have target and feature names for pixel 0 underscore 0. It's 8 cross 8, right? So there will be 64 total pixels. So imagine, so you have 8 rows, 8 rows and 8 columns. The pixel on 0th rows and 0th column is basically marked as pixel underscore 0 underscore 0. Right, 0, 1 marked as.
Here it is also, this is bunch object.
It's a bunch object, yeah. By default, it's a bunch object. And the last one is 7 cross 7, 7 by 7. Okay, so this is what you see here are the names of the features. There are, these are one single digit, right? So there are 10 classes. What is the type of this problem?
Multi-class.
Multi-class classification
Multi-label.
problem. Not multi-label, right? One digit gets one label, right?
Yes, yes.
One image has one digit. One image has one digit, so it will get single label. Okay, and you can also see description and things like that. So I mean, the interesting part for me is showing you the what is a digit dataset dot data 0, which is the first digit. So yeah, you can see that there are 64 values, okay, that are present. I'll write here. So every digit has 64 values. Presenting it. And you can also check the shape of the data, just to see how many examples are there. How many examples are there? 1797 examples. 1797 examples. Each example has got 64 values or 64 features. We can also check the shape of the targets. Got it? So you have to tally this. So you always, it's a good idea to assert this. Assert shape 0. Whether assert works or not. Should work, I guess there is. Assert is not defined. Maybe assert is like this. Yeah. So this assert is true. Right? This is a check. We are performing a check. We are saying that this number over here, which is represented by shape 0, and this number over here, they should match. If they match, that's a sanity check. It's always a good idea to insert an assert statement here. If they don't match, this assert will return an error. Getting it?
So since it's a multi-class problem, it will also make sense to list all the possible values that
of the classes, right? Yeah.
Yes.
So let's list them. Digits. How do you do that? Dot target names. See nine different values.
Okay. So 10 values.
10 values. Yeah, sorry, 10 values. You can also plot this as an image, right? Because there is also, if you look at in this bunch object, right? If I say digit data set, 10 different values, 0 to 9, dot keys, I guess, should work. Yeah, there are these keys. So there is a key called images. So these images, it also has raw images for each of the example. Each example has all these things plus images. So we can also plot these images. Let's try to plot these images. So we can use matplotlib.pyplot for that. So say import matplotlib. Some of these things might be new to you. Don't worry about it. You will get used to it. We'll import this pyplot and we say, let's say plt dot plot. How do we write this? plt dot mat show, I guess. Mat show. We can say digits data set dot images 0th image. Let's see whether this works or not. You see this? This works, right? We can also plot this in gray by saying just gray, plt dot gray. why this gray spelling is wrong or what? Yeah, you can see in gray. This is the image, and what is the target? What is this image? Let's also print that quickly.
Looks like a 0 for this.
Digit. Yeah, looks like a 0, but dot target 0, right? This is 0. Got it? You can also do that. What is the first image? You can see what is the first image. Looks like 1, I guess. Not sure though. 1 is 1. Yeah, this is how you can explore the data. Any questions? So you saw how exactly images are represented. So every pixel here, right? This is 0th pixel. There is nothing here, so there will be value 0 here. Whereas you see some traces here, so this is not exactly white. So this is like this value is 255. Values between 0 to 255 in each of the cell. This is total white, so it is 255, and this value is 0. And these values will be less than 255 but greater than 0. That's how you will see these 64 values for every image. This is a single image. This is a single example. Any questions?
Last time we talked about 28 by 28 in the previous class, right?
Yeah,
So
yeah. This is 8 by 8. So this is a different data set. Last time I was giving you an example from MNIST data set. MNIST data set, the images are of size 28 cross 28.
That is of higher resolution.
Yeah,
this is slightly smaller resolution.
Yeah. That's correct.
Sir, when you were loading this data, it got automatically loaded into the data and target itself, or you had specified that?
No, by default I loaded this, so it loaded a bunch object.
Right.
Okay.
And then
And
how
that
did
bunch
it take
object has got. Yeah. What is the question?
Then how did it come to the data and the targets? It came automatically?
So this bunch object has got data, it has got target, it has got feature names.
Okay, it has it by default.
Yeah, it has got target name, it has got images, everything is there by default.
Okay, thank you.
Okay, so it is very easy to use sklearn, as you can see, right? I mean, I just imported the class and I just instantiated an object, and I call it, and I got the data set here. So as far as data set is concerned, this is very straightforward. I showed you some of the data sets that are already there in sklearn. We'll talk more about this data set API in detail later in this course, where I'll show you also how to load other data sets or your own personal data sets, how we can load them. So we'll discuss that in detail. That's not the point of this discussion. This discussion was about how do you load data set, how they look like, and things like that. So giving you some practical understanding of that. Any questions?
So in real life, this is already somebody has manually labeled. In real life, let's say we are building a machine learning model. Let's say we ask a bunch of people write down numbers between 0 to 9. We'll take it. A human will look at those, and we know it is an image. So it will be manually labeled and stored as either a 0 or a 1, because the computer algorithm can only understand numbers. So essentially, this is a translation process where image is manually labeled, and then we'll use the manually labeled as a target variable in my machine learning algorithm.
That's right.
So I think that is the connect between the question you asked in the previous session. How can we make a learning algorithm, right? Just wanted to close that.
Correct. So data preparation is very underrated task, and it needs to be given a lot of importance now that we want to train algorithms, machine learning algorithms based on data. Yeah, so data processing, data collection is very, very important task here.
So a lot of companies are hiring actually data labelers because image recognition and all that. There are
that's
labelers, but there are a lot of jobs in that space also.
Yeah, that's right. And let's say if you're also solving this problem, you need to first write a spec where you need to give data annotation guidelines to the raters, saying that how the human rater should be labeling each of the data point. So that's another process that one has to go through. I mean, it's important to note that, because you will be solving real life problems. Sometimes data will be present, sometimes data may not be present. So if data is not present, you are going to also take up the task of data collection or data labeling. There you have to write basically rater guidelines, annotation guidelines. And one single example, we give it to multiple raters also to understand the complexity of each of the example. If all raters got it correct, then it's great. If some of them got it correct, some of them didn't get it correct, that also help us to understand how difficult is the task. Yeah. So there are a lot of metrics we calculate called inter-annotator agreement and things like that, which is of course beyond scope of our course, but I'm just sharing it here so that you have complete understanding of the process.
Thank you,
Yes,
sir.
Ravi. Yeah. Any other
Sorry,
questions?
sir. That probably it was just my breath. I'm sorry, nothing.
I see. No problem. Any other questions? So I hope this was useful for all of you to understand how to load the data at least, right? What kind of data sets are available for us to play with in sklearn. So I showed you a couple of data sets. We'll come back to dataset API later in detail. We'll also see various other aspects of that. How to load your own data, how to load data sets from, let's say, OpenMLP, right? So we'll see all that later. Okay, so let's move on to another topic now. We just have 15 more minutes left. I'll try to at least introduce you to that topic. And all right, so now, the next topic is really, we need to understand how ML works, right? What are different components? What are different components? What are the steps? So all of that. So before doing this, what we'll do is we will first experience its working by playing with it, and then we will theoretically we'll write all the steps, all the theory about this. So all of you will first go to, I will put a URL here. So you'll do some practical. You follow along. We'll go to TensorFlow Playground. I will verify the URL whether it is working well. Okay, so type this URL in your browser. Go to playground.tensorflow.org. Okay. Playground.tensorflow.org. I'll also put this in a chat. Okay, where is our chat? All right, so go to this website. I hope many of you are here. So you can see something like this in your browser. Is my screen visible to all of you?
Yes, sir.
Yes.
This is the default state. Now, first of all, click this button and get to this state. I'll first explain what all is there. And we are going to play with this, and in this class and also remaining part of this class and next class, we'll begin with this. So I told you that data is the most important part. So there are different type of data sets. This is, by the way, a toy setup. And you cannot really load your own data sets and other things. There are few data sets that they have given. There's one data set which has got two classes, and we will basically we'll basically try classification problem on this. This data set, these two classes are separated, and we can always draw a line between them. So they are linearly separable. This is another data set where two classes are separated by a circular decision boundary. There will be a circle. If you draw, then only you will be able to separate these two classes. This one is even more interesting. We'll have to draw even more complex decision boundary to separate them. And this is the this is the most difficult of the data set in terms of finding the decision boundary. So these are all data sets. There are various parameters of the data set, how many of them you should be using for training and test. We have not talked a lot about it. Or did we? Did we talk about training validation in the last class? Not sure. Probably not.
No, sir.
We have not talked about it. It's okay. Yeah, that's okay. We'll talk about it later. So right now, yes, keep it to, let's say, what are default? 70%. Put it to 70%. These are clean data sets. If you add noise, what will happen is that the classes, the points from the other class will start getting into the other class. So there will be a lot of disturbances. This is not, and most of the real world data will look like something like this. It is never clean. But we will start with a very nice setting, serene setting where there is no noise. Okay, and don't worry about this parameter batch. It's not needed. And every data point is described with two features, x1 and x2. There are two features for every data point. Okay. And now we have a model, and that model uses these two features, and it basically decide what kind of line to draw between these two classes. Okay. So that's the model part. So we have data. So now remember the components of machine learning model. We need to have data. Second, we need to have a model. Data, what do we, data has got features and a label. Then we need a model. Model is a rule or some kind of a mathematical expression or mathematical function that takes the input to the output. And once we have a model, we basically kick in the model training process. And that training process is done through what is called as an optimization algorithm. And we optimize some kind of a loss of the model. We need to define how the model loss looks like and things like that. We'll talk in detail about it. So we define, when we use a specific model, we try to understand how good are we on a given task. So how good are we on a classification task? Let's say I use this particular line, the one that is shown here. If I use this line, how good I am. So I am now able to mostly do well, right, on both of these things. So you can see here training loss. There is slight loss in training because we are not showing the test data. There are some test examples which are at the boundary or they are crossing the boundary. So there is some loss that is happening here. So you want to minimize this loss. How to measure this loss is a part of other discussion. We'll take it there. And we use this optimization procedure to run to reduce this loss, and that's basically a training procedure. So we have data, we have model, we have loss, and we have optimization procedure, and we have a metric like loss. Here we'll again use loss as a metric. There is a metric which is called evaluation metric. So there are these 5 different components of any machine learning algorithm, and every machine learning algorithm that you might have studied in MLT and that we are going to study in MLP through practical, we'll be defining these 5 different components. One is the data, the model, loss function, optimization procedure, and the metric, evaluation metric. In sklearn, the model itself has got the loss function and optimization algorithm tied to it. Sometimes it is optimization algorithm is tied, or you can use other optimization algorithm. So in sklearn, really there is training data, there is model. Model has got its own model, it has got loss, and sometimes also the optimization procedure. And then we have got metric, the evaluation metric. So remember, there are 5 different components. In sklearn, we need to really set 3 or 4 different components. Now what we'll do is, we have this particular model, we'll try to train this model, right? So by training the model, so first, we initialize these weights. So we are going to learn the weights for every feature, right? So we are going to initialize this weight. So I randomly initialize these weights to some values. And because of that, this is the line that we have gotten. It is already too good line, but we'll still see if we can do better. So currently the loss is 1.6 on training and 1.6 on test. Now I will make one iteration on the training. And with that one iteration itself, I got the training loss to 0 and test loss to 0, which is super great situation for us. Not with just one loss. Sorry, I missed it. Sorry, I just make one step. Okay, let's rewind. So initially this was the situation. I just make one round of training. After doing one round of training, I got the loss down to 0.021. So I got a new line, right? If I move ahead, the loss reduced further and line got slightly changed. Keep your attention over here and here. Now I'll make the third step. You can see that the line changed a bit. Again, this particular line changed a bit. And this value also changed. The training loss has gone to 0.8. And these two values will also change. The weights will also change. I made the fourth pass. This has changed again. Line has changed slightly. These weights have slightly changed. So keep an eye. And I can keep doing this. And if I just press this button, this will go really fast. And you can see that we have gotten almost a zero error training and test error. And this is our final predictor. This is the boundary that separates these two classes. Understood? Understood this part? We are not doing anything. I'm just showing you how the training process works. Any questions?
So here it's a dummy data set. So all the orange points and the blue points, they're perfectly separable.
Yeah, they're
In real
perfectly
life,
yeah.
there will be some blue on
Correct.
the orange side and some orange on the blue side.
Yeah. And
Sir,
go ahead.
if I have a real data set, can I check the error from applying this method?
Yeah. So in real world data set, unfortunately, we cannot get nice visualizations. First of all, we have more than 2 features, so we cannot get something like this. But these losses, these figures, we can always calculate, and we can also calculate this type of curve. I'm going to talk a lot about this. This is called as learning curve, right? And we always have to keep an eye on this. So if your model is getting trained properly, this curve has to go down. It starts with a very large error, and as you train model, the loss has to go down. If your loss is not going down, then there's something wrong. Either your learning rate is too high. So we typically reduce the learning rate, and there are a bunch of strategies. We'll discuss about them. So this is a learning rate. Learning rate tells us how fast we are going to make changes to our weights, right? Depending on the gradient that we calculate. This uses by default a gradient descent algorithm. I don't want to use too many of the jargons, but some kind of optimization procedure. And learning rate, so learning rate tells us how fast we can move in that optimization landscape. I'll give you a very, very simple analogy. So this optimization algorithm, right, that we are going to use is like, let's say all of you must have done trekking someday or the other in your life. And after we do trekking, right, we reach to some point, some highest point in the mountain or on the hill. And after reaching there, you want to come down to the valley, right? Because you want to eventually come there. So what do? So you are there at a point, you look around, you figure out what is the steepest direction that is taking you down. So you will follow that direction. Now you don't want to commit yourself completely to a direction, because it might happen that that line might later take you somewhere which is away from going towards the valley. So you don't want to commit fully to that. So you say that I'm going to only take some steps, right? And how long that step will be is decided by the learning rate. If I use small learning rate, then you might step a few steps, and you will again check what is the direction that is taking you down. If I use a very large learning rate, then you will walk some distance, and then you will again do the same thing. And you keep doing this until you reach the valley. That's a simple algorithm that is being used. This is called as gradient descent algorithm. And we use most of the time variations of this gradient descent algorithm for optimization to learn these parameters. I will talk a bit more about these things later in this course. But here, if I use a very small learning rate, you can also see, right now the losses are pretty high, 1.8 on training and 1.8 on test. So if I just make one step, see, it is going to reduce very slowly, because learning rate is very small. So you can see that even after 500 iterations. See, this loss is coming down very slowly because you are walking very slowly towards the valley, right? But good news is that it is coming down, so learning is happening. If it doesn't come down, that's a bad news. If it doesn't come down, you have to slow down. If it is doesn't come down, meaning that you have taken a wrong direction and you're probably going away from the valley, right? So now see, it has done 1800 steps and it has reached to some loss. Now increases the learning rate and retry. Keep an eye on weights also. Weights also changes. Now you can see that this is happening pretty fast. After nearly 200 iterations, you have very small amount of training loss, right? If you increase this further, you see it even quickly. This happened only in 78 steps. Are you getting this? So I'm just showing you some of these things practically so that you understand. Is this clear?
Clear, sir.
Yeah. So play with this a bit, and in the next class we'll again start with this particular point, and I'll show you some other interesting facts that will help you to basically get a good intuition about how machine learning algorithm is working. What is it that we need to pay attention to in the real world? How do you compute those parameters and things like that? So we'll discuss that in the next class. Any questions from today's class?
Sir, from where I found your notes?
Yeah. So Manoj will
I shared
upload
it
these
there.
notes. Manoj has sent it, right?
I shared it.
Okay. Manoj has shared it.
It's already in calendar. It's in
No,
the
only the video link is available, or you will upload the PDF
everything.
or
Everything is there. Everything is there.
Yeah, just go there, check it
in
once.
the calendar.
It's in the calendar. It's in the description of this video. If you go to YouTube, in description you will see there is a link for this.
Today I have see the calendar, but okay.
Please check it. I mean, it's there. It's there. We are not hiding anything. We just want to share everything that is out there.
Sir, can I ask a question? It is not related to class, but it is related to the machine learning. Or sir, I have a problem. Actually, I am a machine learning engineer, and sir, I have a problem that I am dealing with a project that want to recommend the products to the user who was or who are interested in the product. Something like biscuits, Parle-G biscuits. Okay. So sir, I am building recommendation system using the first I built using the cosine similarity, but it didn't work because it has a sparse matrix. If the data is 200, 20 million rows, then sir, it won't work there. Right now, I am using the TensorFlow, but sir, in TensorFlow, I am also facing the problem. If you can suggest me any book or any article or any something a course that is related to the representative learning or the recommended system.
So TensorFlow itself has a course called recommendation course. Go to search for TensorFlow recommenders. You will get more information about it.
Okay, sir. Okay, so yeah, sir. That's I'm using and also following the lectures that are shared in the YouTube.
Yeah.
I think there is a person is Chinese person, maybe it is American. He's an
Right.
American. He's built that system and he's giving the tutorials for that. So it is the same resource or any particular
Same resource.
paid
Same
resource
resource.
or something.
No. Same resource. Same resource. I'm talking about.
Okay, okay, sir. Okay, sir. Okay, sir.
Yeah.
Thank you.
No problem.
Yeah. Thanks a lot, sir.
Okay. No problem. Thank you very much.
Sir, I have one question on the project. Basically, there were some submissions that were to be done by yesterday on the Kaggle ID and the name of the notebook. Kaggle ID, I understood it from the session as the name that appears there, and I entered it. For some reason, it was showing as wrong. The answer was wrong. And again, the date has been revised. So is there anyone in the session, like any teaching instructor who can actually help me with that? There is something wrong with that. I don't know what exactly I'm doing as a mistake there. Kaggle ID is not my roll number.
Yeah,
Kaggle
even
ID
the
is
Kaggle notebook, the final notebook which I submitted
the
as
name.
instructed,
Yeah,
even that is
that
showing
is
as
come
wrong.
as error. So we don't know what is going wrong, and the data now I cannot show you what the error is because the data has been extended. It is all null. So it has gone back to its original state. But I'm sure if the same logic is used tomorrow when the deadline passes, it's going to come up with the same error. I don't know what is going on there.
We'll discuss this internally and get back to you on this.
Yes, sir. Yes, sir. Thank you, sir.
Okay. Thanks. Thanks for bringing this.
It posted out in Discord also.
Yeah.
Unfortunately, I do not have the evidence to show you that it is coming as a mistake. So I'm at a loss as to how I can. Do you want me to show you the snapshot of what I had submitted so that you can validate it, or?
Yeah.
Yeah,
share that in Discord. Okay.
Yeah, I will do that. Yeah. All right. Thank you.
All right. Okay. Fine. So let's log off. See you on Tuesday.
Thank you, sir.
Bye.
Thank you, sir.
Bye.
Thank you, sir. Bye, sir.
Thanks.
Thank you.
Have a nice weekend. Bye.
Thank you.
Thank you, sir.
Bye. Thank you, sir.
Bye.
Thank you, sir.